Hello, welcome to another Random Code stream. I'm going to be working on this issue again this morning. I have off today, as a lot of people do, because it's Martin Luther King Jr. Day in the US. And, I'm going to take this time to spend a little bit more time working on this thing that I've been working on for the last, I think, 2 or 3 streams, which is a extension method to give you the option to not have to show all of the information that's in a big integer. Because if your number gets to be about 100, 500, 1,000 digits, do you really want to, maybe you want to print all that, or maybe you just want to see like the beginning and or the end. So that's kind of the idea with this. And I've been trying a couple different techniques, and I think I've got another one I want to try this morning and see if that's any better or worse. So let me get my music going here. All right. So the thing that I want to try is something like this. The current, do I have that up? Hold on. Yeah, the current results showed that my first idea, which is to basically chop off the left and right parts, but I also then do the absolute value of it and I get the number of digits this way. This feels like, especially as you get bigger numbers, it's a bigger allocation. Though, as we saw, at some point the allocation or the speed switches as the number gets larger. So the number of allocations, though, always is smaller, but we want to see if we can get something that gets us something fast and also something with few allocations. So this one does some math to figure out the beginning and end parts, and then this one just simply does a ToString and then chops off. And so it's not surprising that this one has a little bit more allocation work to it. And you see that with the results. And again, we're just talking bytes here. We're not talking gigabytes. But still, if you can make something more efficient, the better. So the idea that I have now, and I stumbled across this at the end of the last stream, which is BigInteger has something called get bit length. Okay. And so that tells you how many bits are in the number. So power of 2. So then I thought, well, how do you translate that into the number of digits? Because if in binary there's two digits, 0 and 1. In base 10 there's 10. So how do you translate that? And did a little bit of math and used Wolfram Alpha to figure out this formula here, the real solution. And that's what you see translated here. So we calculate the denominator, that's log 2 plus log 5. We store that there. We raise 2, and actually down here is the way we really are going to do it with big integer pow and big integer log. And then we also take the ceiling of that because we want to round up always if there's any fractional part. Okay. And so that will get us the length. So in this case, we don't have to worry about the number being positive or negative. As you can see up here when we do the calculation, the number is negative, but we get the bit length as being 61, but the actual number of digits is 19. And that makes sense, I hope. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19 digits. Okay. And so we did this for I to 1 to 10,000 just to make sure that this calculation works. And actually, I'm going to run this while I keep talking because I want to do this for just negative numbers and show that hopefully we get the same thing, is that the number length here, and actually, no, this is going to be wrong. This is going to be off because no, it's not. I want it to stop. I don't think there's a way to stop this in here. Yeah. See, they're all going to be off because you take the literal length of what's outputted here. It's giving you the extra negative sign here, and that's not what we want. Okay. So, like here, if we say console.write line, and we say length value ToString length, and then let's just turn this down to 10. We're going to get 10 errors. What's the problem? Oh, we need, nope. Yeah, see, it's the extra minus sign that's just showing up when you do the ToString. So that's all we're seeing here, down here. But it's just off by 1 at that point, and we can handle that. So the point of why I'm doing all this is because now we can just get the bit length, and that gives us the actual length using this calculation of the number of digits. We don't have to do what we're currently doing right now, which is to do a positive absolute value and get another big integer. Okay. So hopefully the idea is that we can use this to get the size of the number and do it hopefully a little quicker. Maybe not. I don't know. But we can use this because now to get the left, this is what the left part is doing. We can use this and then literally just take that value. We don't have to do any massaging on it. The remainder is going to be negative. So we do have to, when we do the ToString on that, we're going to have to be a little bit cautious about saying if it's longer than what we wanted, then we need to trim that. But, or start substring 1 and then move on. But then we don't have to do any of the science stuff here. So I want to do a ToString 3. Okay. So let's do a ToString 3. Same thing. We're not going to do this though. So what we want to grab is the bit length on self. Okay. And we're going to want a const of this. And then here we want to get just the length of that. And then this is, because the bit length is a long, I think, right? Yeah, but we're not. When you do a big integer pow here, it has to be an int, so we have to cast it. Bit length. Okay. And this should hopefully get us the length. Okay. Now what we want to do is the calculations that we were doing here, except we're going to modify them slightly. So the left format is going to be literally just self here. This is the number of digits. Yeah, let's keep the name same. Except we're going to want to do that. We have to cast that. Yep. And now here we don't, in fact, we can just take this off now because we don't need to do that part. And so here what we're going to do is we're going to say the left format is the left digit count. It's this. Hold on 1 second. This will work, except we don't want to. What I really love is a ternary that lets you do like a function or do a block here. That would be really nice, but that's not an option. So what we're going to have to do is something like var right format is equal to this. And now we say if right digit count is greater than 0, then we're going to do this. So that should get us that. Now, if we wanted a number of digits in the length, if right format length is actually greater than the right digit count, then what we need to do is reassign it and say is equal to that substring starting at 1, and then we can change that to being a range operator. So that's just going to chop off the negative sign if it shows up there, and then we just return the format and we're done. Okay, so let's go add, not that. We'll come back to that. Let's add some, no, not there, to tests. Because I want to do this for ToString 3. Just to do a quick sanity check that this is actually doing the right thing for 3. They 2 passed, 10 failed. Well, that's great. Hold on again, please. All right, so what actually passed and what? Oh, okay. So we do have to do a little bit of a trick here. So if we didn't want any digits, that's one thing that's breaking here. But it is negative. Then we have to include the sign here. So if we don't want digits, if we want digits, we put them in there. And then it will automatically put the minus sign in, or at least it should be doing that. Else, if self.sign, and what is that again? If it's -1, then we're going to do this, else that. Okay. So what else is still going to break? So now we're down to it's so weird. Why is the numbers aren't showing up right? Interesting. So some are passing, right? Wait, I'm a little confused. Let's run this again. Why is it showing 2? And 4? Okay, so it seems like the math for any of the, when you're doing the leading, is incorrect. Yeah, okay, so let's take a look at that. Oh yeah, we're in release mode because we were doing benchmark tests yesterday. Okay, so if I say self ToString length, it's 43. How many digits do we think we have? 44. What am I doing wrong? If I do this, let me do that. Oh, shh. That sucks. Is it going to bring it back with the right? Yes, okay. Whew. I did not mean to close it. Wait, there we go. Okay. Back to normal. So we're getting 19 and 19. So if I go back to my original test here, yeah, we're off. I was afraid of this. The reason I say I was afraid of this is because I felt like some of the precision is going to get skewed based on this math that you're seeing here. Now, what we really should do, by the way, is throw in this up here. But then we can say this is bit length. And oh, right. We got to do an int cast here. Yeah, it still doesn't matter. Math is still going to be a little bit off. And so if we do this, let me say console.write line result. And then we put result in here. Yeah, and since we always round up, in this case that's incorrect. We're going to get one too many. So this isn't reliable. We can't do this reliably this way. And I don't want to deal with all like I think this is like mathematically correct, but I just don't think we're going to get the right kind of precision that we need, and to do this correctly every single time. Like with this, that gives you a length of 14 and 43. But if we say 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 9, you run that. Now the digits is correct. But how would we know? Like, how would we know that we want to go up in some cases and down in others? So I think I'm going to scrap this idea, which is fine. I mean, this is kind of why we do things like this. So, okay, why did I put a JS type in there? That is bizarre. Yeah, if we could only take well, we're using positive self all over the place after this. But what we could have done is something like this. Because then this gives us the formatting handling the original number with the right digit count, which is what we're able to get up here. Here's a question that I have. Is it cheaper to do an absolute value here, which probably just does? Like if I do F12, let's see if it can figure out. Yeah, it's literally just doing a minus there. So I don't think there's going to be any kind of optimization to like us doing times minus 1 or whatever, you know. Though what we could do is say, if it just returns the value back, this is a read-only struct, so it's going to make a copy. Only in the case, though, that we need to actually have like, I'm wondering if I can somehow get away with not doing a copy at all. Because even though that this is doing big integer value here, it's returning it, but it's returning the copy of it. Because big integer it's a read-only struct, but it's not a rough struct. So I don't think what it's going to do is I'm just playing with ideas here. Get format. Ref. So we could say here, if self dot sign equals minus one, else this may not work out, but I'm just going to give it a whirl because I got some time. So what we want to do here is take this and put it into here. Now we don't do this. We just say self. Int left digit count int right digit count. And then we just say whatever the self is here and here. And then we don't have to we do want to do this, except we want to take this off here. We simply want to return, because we're assuming what we're getting in here now is a positive number, right? And so here we can just literally say get format of self left right. But here we want to say we are going to put in a minus one. And we're going to say var positive self is equal to self.abs. No, BigInteger dot absolute value of self. And then we pass this in here. Hold on. Oh, and then we need to say return here. Okay. So the idea is that for positive values or 0, we could throw in an optimization for 0, I guess, but we're not going to worry about that right now. Is that we're not going to be making a copy here if the number is positive. If it's negative, we will. We have to, because we need to get the absolute value of it. And big integers are immutable. So unfortunately, we have to do this. But then at least we can pass it in here. We're not making a copy of the big integer when we're passing it in here. Now, first thing, let's get rid of ToString 3 because we know we're not going to go down that path. Do all the tests pass. They all do. Okay, so now what I want to do is come into this project, which we do have these numbers. Now I want to run it again, and I want to see what kind of results we get. So let's go ahead and run it, and this is going to take probably about 5 minutes to run. If I remember right from yesterday, it should take some time. So, how's everybody doing? Anyway, just checking some messages. Don't know if this is really going to help. But it's worth at least seeing if something like this actually does. So once all that data stops scrolling by my face, I will parse out all the results and then we'll see if it did make any difference or not. I still think I'm going to take the first approach because it is consistently fast. It's consistently less allocation than the second approach. It's not always the fastest, but we're talking nanoseconds, you know, and maybe it's worth doing, like I said, a cutoff. But even if we do a cutoff to get speed, we're going to lose memory allocation. And to me, I would actually rather have consistent. In this, you know, if I had to pick two, it's like having a case where you know it's always going to be less memory allocation, and maybe for smaller numbers, it's going to be less performant. But there's a crossover. When your number gets somewhat bigger, which you would probably want for a big integer anyway, it's going to be bigger. One thing that just went through my head too is what happens if the number that you have is smaller than, that's a case I have to consider. So let's say I said my number is 1, 2, 3, 4, 5. So that's 5 digits long. And what I wanted to do is show 4 on the left and 4 on the right. Well, that's bigger, so you would just return the number itself. There's no point in trying to do that. What would happen if I had 1, 2, 3, 4, 5, 6, 7, 8? That's equal to. So the size of the number has to be greater than the number of digits you want to show in total. Strictly greater. If it's less than or equal to, we just do a ToString on the number and return that, because you're not gaining anything by doing what we're doing. So it's not an error. It's just that's a case that we're just going to have to handle. Otherwise, I think our math is going to screw things up. So that's more of a correctness thing than anything else. And in both cases, we would want to do that. Either approach we take. But again, we're going to see what this comes up with. 6 of 20 cases remaining, 1 minute to finish. That's what it says. It is a cold day in Minnesota today. What did it say it's going to get up to? I think 4 degrees Fahrenheit. Yeah, -5 right now. That is brutally cold. I know some people are like, oh, well, here it's like -20 or 30 Fahrenheit. You know, I'm just saying they're both cold. They're both cold. And my wife and I have to run to a hardware store for something this morning, so that'll be fun getting all bundled up. All right, finally. Now I'm not going to try to look at any of these numbers. I'm just going to grab the data as we did before. And then let's come into here. And now let's try to move stuff around. I don't want to look at the numbers too much because I don't want to get biased. So we have 500 here. Let's take that out. Put that at the end and put in a space. Okay. And now we need 100 and 101. I don't know why it does this. Like why it just doesn't show you. This is 10 and 20. Which we would want to put here, right? Because that's 20 digits long, and then 21. And then this one we want to put after 50. There, okay. Well, we didn't gain anything. If anything, we made it worse. I mean, there's still the switch off, and there's still the fact that, but the original way we did it actually was doing less allocation across the board. Now again, as you run these, this was run yesterday, this is run today, you know, the mood of my computer, but it looks like the numbers for the ToString 2 on the mean speed-wise are pretty consistent. It looks like, you know, again, okay, fine. We really didn't, I think, affect anything by having a positive allocation there or not. I don't think we really changed much of anything. Maybe, but we're talking a nanosecond or two. Yeah. Maybe the allocation it's even less in some of the cases. Yeah, it actually goes up. That's what we did. So I think that to me is pretty conclusive that what we had before was actually fine. So let's back all that out. Thank God for the undo pattern. We want to basically get it to where it's there, right? And now we just don't do this, and we don't have that, right? We should be able to run our tests, and they're good. Okay, so I think I'm pretty sold on what we have here is going to work. And let's get rid of ToString 3 here because we don't need that either. And we don't need this JavaScript thing in here. I don't know why it keeps doing that. Okay. So, yeah. We can actually just get rid of that now. Okay. And this will just be a baseline and just show what we have. Okay. We can get rid of the ToString 2 tests here. Run all of our tests again. All right, now we want a case to handle where we want to say, here's the number of digits we get, okay? And so what I want to say here is if the number of digits is less than or equal to left digit count plus right digit count, then we just do that. Else that. Now that shouldn't have broken anything. Okay, but now we want to have a test in here to say that if we have something like 1, 2, 3, 4, and we want 4 digits on the left and 4 digits on the right, what that should just give us is 1, 2, 3, 4. Now, if we even do something where it's equal, it will still return that. And then the same thing for the negative case. Huh. Good luck with my math, huh? Okay, so I just am off of my calculation here. So the number of digits we want is 4, the left digit count and the right digit count. So digits is 4, this is 8. 4 is less than 8, so we should return this. Oh, that's what we want to do. There we go. Okay, so this way we can say, hey, if the number's got to be strictly greater than that summation there. Otherwise, there's no point in doing any of the formatting. Okay. I think at this point, we have what we want for this solution. There could be possibly, and I'm not going to say that there might not be a faster way to do this. It's entirely possible to do that. In fact, it may be, like I know there's this thing, string create, that I think the original solution gave as a possible, like, way to handle this. And that might be something to consider to do this even a little bit more, quicker, I guess. If you look at string create, to control the formatting of the specified interpolation string. Yeah. But that could, I don't know. I mean, again, at this point, that's something to come back to later, if ever. If this does what we want it to do, then that's what we got. And I'm perfectly happy with that. All right, so I think what I'm going to do now is say, oh, wait, hold on. Did we update the changelog? Yep. Okay, cool. So let's do git commit. All analysis is done for now. Time for a merge. Okay. What? Is that what I wanted? Okay, so do this. Let's do the dance. Let's push this. So now if we come back up here for this, we should see that we just did a change. Yep. All right. Delete that. Delete that. And then let's come into here and go into our issues and say this one is done. It is finished. Okay, it's near the end of my time. I usually try to keep them around an hour. And if I look at my milestones, I think for this one, there's 3, but I think I might skip one. The one I really want to do is this one, the static extension ones. And that one should be pretty simple. I might just do that on my own time. And that gives you the ability to then use these static extension methods. Use these extension methods on the static type random number generator, which will just use the default, whatever create gives you back. And that might be really, really cool, because that way you don't have to have an instance of it. You can just go on random number generator yourself. So that might be just something I do for my own pleasure and just do that my own time. And then in a future random code stream, I'll just do something else. So with that, I'm going to end the stream. I want to thank everybody who's been watching either now or in the future. Please subscribe to the channel if you haven't done so already. I will be doing a control playthrough stream this afternoon, probably starting around 1-ish or so. And I won't be doing a stream tonight, but just another stream this afternoon playing control. But with that, I am done with this stream. Thank you all for watching. Take care, and I hope to see you in the future.